I'm gonna entertain you all or inform you all about GUI testing, graphical user interface testing, for the next 45 minutes or so. And before, well, let's see. First off, starting off, I'm gonna just give you a little bit of a narrow down what we're talking about. So we're all here because this is the topic of software engineering. That's where I'm getting my docent, hopefully. And software engineering can be divided into roughly 3 parts, which regards then the specification of software, the realization of software, and then what I'm going to talk about today, which is the verification and validation of software. And verification and validation can be divided in multiple different instances, but one aspect is the predictive verification and validation, which relates to things like formal methods, mathematical proofs, and stuff like that. And then we have the more reactive testing, which often happens after we've written software, and that is sort of the route we're following for this presentation. This reactive testing can then be divided into manual testing, which regards then humans sitting and testing software, following specific specifications, or just exploring the software, checking for defects and bugs, etc. Or automated software testing, which is what I'm talking about today, where we have automated test cases that are either created manually by humans or generated automatically by computers and then executed automatically. So that's the definition for today. And this automated testing can be done on multiple levels of system abstraction. It can be done on very small components of the software, which is almost very close to the code or the code itself. It can also be on an integration of components, or it can be the entire system. How does the system work within our computer or our phone or whatever? And that's the level of abstraction we're talking about today. And within system testing, we have graphical user interface testing. And for this type of testing, we have non-visual graphical user interface testing, and we have visual GUI testing. The non-visual can be API level interfaces, technical interfaces, or through something called the document object model, DOM for short. And I'll get back to a little bit later what that is. For the visual approach, we have the actual graphical user interface, meaning what is actually shown to the user on the screen. So what we interact with as humans. So what I'm talking about today is graphical user interface testing, visual or non-visual, for the purpose of system testing, which is automated, and reactive for the purpose of verifying or validating software. Everyone following so long? Yeah, very good. If you agree or not, that's a different question, but we'll save that. So the objective of graphical user interface testing is then twofold, or there are 2 different objectives. One objective is to verify the graphical user interface correctness, meaning that everything looks correct on the screen. But there is another more common purpose for GUI tests, at least in industry, and that is to verify the system's correctness through the graphical user interface, which means that we're executing test cases against what we see on the screen to stimulate that. Well, if I click in this sequence, does the application crash, or does it still work in a correct manner? And that's the more common approach. And the approaches that are commonly used then, which I've mentioned, is visual, DOM-based, or technical. And in order to understand this, we need to look at the software as a set of layers, where the lowest layer is the source code, the programming, the code we've written, and then that consists of functional components, which are grouped into feature components. And on top of this, we have some graphical user interface structure, and then we have the visual graphical user interface as we see it. And these different approaches then interact on different layers here. So the technical approaches interact on these lower layers, so closer to the source code, whilst the DOM-based is completely on this GUI structure. And I'll get back to a little bit more what that means later. And then the visual is against the visual interface as we see it as humans. And for the purpose of this presentation, I will also introduce a new layer, which is also the augmented GUI. And this is related to research we're doing, which I will get into. So how do we utilize these approaches? And when I mean utilize, I mean basically how do we use them in industry to get some value out of it? And the most common way still is to write some type of scripts for this. So it could be, for instance, in Selenium, which this example is for testing web pages, driving the web pages to go from one page to another. And this is written in completely in code in the same way as you write your software. But then there is also specific tools where you write in custom languages. And here's an example from a tool called Securely, which is image recognition-based testing tool, which explains why there are images in the script. And the script is commonly like click on this image, find this image, check if this image exists. And this allows you then to automate basically any system that has a graphical user interface. Then there are also a lot of offshoots of this type of testing. For instance, model-based graphical user interface testing, where you use models, you draw these models, which are supposed then to explain the behavior of your test cases, and you connect them to some type of GUI test code, which runs the actual tests and runs the model. And then lastly, we have then some novel approaches like augmented testing with this augmented layer, which I talked about, where you record and replay everything on top of this, on top of an augmented graphical user interface, where everything is visualized on the actual graphical user interface as it's shown to the user. And okay, I've talked a lot about them already about graphical user interface testing and tools, but why am I talking about this? Well, one reason is because here is a model of what software development in many companies look like. Many would refer to this as an agile process, despite the very waterfallish steps, but I claim that this is a good model for agile software development, where you start generally with some specification of some kind, which is what are we developing. This is handed over to developers, and these developers nowadays in industry also develop unit tests, these small tests to check the code. Once they're done, either in teams or in teams of teams, they integrate their little components into larger components, and they test them in integration tests. These integration tests are then done among all teams to create a system release candidate. And this release candidate is given to testers, which do system testing. So we're getting more and more chunks of the system put together and tested. And finally, it's deployed to our users. And as you notice here, the system testing box is marked in orange. And the reason for this is because this activity is where GUI testing comes in. And this is mainly done still in industry in a manual fashion. The problem with manual GUI testing is that it's very costly, it's very tedious, and therefore error prone. And the tediousness comes from these specifications, these test specifications being quite large and quite boring to run through. I've done it myself, it's no fun. And this leads then to human error. So an attempt here is to automate this process to make it more predictable and replicable in practice. Another reason for automating the GUI testing is this tendency of shift left, which some people in this room are working hard for. And what that means basically is that we're trying to take activities that testers do today and move them over here to the developers. So it becomes the developer's responsibility to do the testing as we're doing the development. However, an issue with this is that these graphical user interface tests, they lack proper tools and practices for developers to do this in a good way. So therefore, there is a need then for this research into GUI testing. So let's take a quick look into the past then. What has happened in the area of graphical user interface testing? And this is based on a very unsystematic literature review I've done. But the first paper I could find about this is from 1983, so almost 40 years ago. And right, me in math, 40-ish years ago. This paper then discussed a tool where you could record little test cases with exact coordinates on the screen, and then it checked if the test cases were correct with image recognition. So it compared a screenshot of, after I did these clicks, I took this image and I compared it to another image, did everything work out? And that was the first instance. Then after that, there was some work on by Yip et al. On some practices and some tools. But this red paper that is marked in red here was particularly interesting because they started talking about the challenges with graphical user interface testing, which included two things to remember. There were multiple things, but two things that are particularly important. First one was, how do we identify buttons and fields and stuff on the graphical user interface? That was the first one. The second one was, how do we synchronize the test cases with the execution of the software? And the easiest way to explain that is that if you use a web page, sometimes when you log in, sometimes you click in, log in, and the website responds instantly, right? So you switch to the next screen. Other times you input stuff, and it takes a little bit of time before it loads the next screen. And these test cases need to take that into account when they execute so that they perform a click and then wait an appropriate amount of time to do the next click. And this is a challenge. And this was reported then in 1992. Okay, so we remember that for later in the presentation. Then in the mid-90s, 94, was a dissertation where they looked at the entire area of UI testing and looked into the future, what might happen. And this paper or this dissertation predicted the use of model-based testing, AI, ML, et cetera, which we have today or doing research on today. So that was very interesting. But this is from the time when GUI still looked like this. So somewhat less complex than we have today, maybe. Google has come a long way, or I don't know. Then continuing on, we had more tool papers, and here also at the end of the 90s, a little bit of more of a discussion about the costs of using this also in practice. What are the benefits or what are the drawbacks? And so that was an early indication of that. Then in the beginning of the 90s, enter a giant, Professor Atif Memon, who basically wrote a book on GUI testing, and I had the privilege to work with him. But he basically dominated the 90s and still dominates, but still dominated the 90s. And what I found interesting then was a paper from 2005, after all of Atif's work, was a definition of what GUI testing is. It took only, well, 20 years to figure out that we might need a definition of what we're actually working with. That showed up in 2005. Continuing on, there was a little bit about industrial relevance for GUI testing. Same as here in 2010, a little bit of work on Android mobile-based testing that started to become a thing in early 2010s. And then some papers on tools, and in particular, the second one I mentioned here from E. Börjesson, nowadays known as Alegroth. So my first paper showed up there. Which was one of the first papers in graphical user interface testing from an industrial environment, a research study in an industrial environment in Saab in particular. Then we had an early paper from Fraser and Seller on search-based software testing, so a little bit more machine learning aspects. And then in 2015, E. Alegroth, at this point in time, me, published my dissertation, which is titled "Visual GUI Testing Automating High-Level Software Testing in Industrial Practice." And I will talk a little bit more about that later. And then we have a bunch of work now getting into the 2020s on AI and ML-based graphical user interface testing. And then in 2021, we have one bibliometric study and one systematic literature review, which I will both talk about a little bit later in the presentation. And so if we look at some descriptive statistics from this analysis, mostly taken from this bibliometric study that I just mentioned, we can see here how the number of papers in this area, how it's growing, and it maps pretty well then to this exponential curve. So we can see that there is a growing interest still in the research area, thank God, which means that I might continue to do this research for a while. But we see here that it keeps growing. But we also notice that the area isn't that big, 744 papers since the early 90s. It's not extensive, but still, that is the area. And if you look a little bit closer in what have we been researching within this, we see here some different graphs that show what were the main things that we looked into in these papers over this time. And we can see here that model-based testing has always been large. We see here the rise of AI and ML. We can also see that record and replay and certain things have sort of continued to be relevant over a longer period of time. So that is basically what we've been studying. And this paper, which I got these graphs from as well, they also looked at the most influential authors in the area. And we can see here that Professor Memon, which I mentioned, is #1. But we can also notice that this guy, me, happened to be #3. I don't think that's a good thing for the area necessarily, but we'll see. You know, I'm still on the top 3, which is nice. So I wanted to brag a little bit. I'm top of some lists, at least. And as I mentioned, the title of my dissertation is this: Visual UI Testing, Automating High-Level Software Testing in Industrial Practice. And this was my thesis was composed by a set of research papers, all performed in industry, all of them except one, where we looked at the applicability and usability of image recognition-based tests, GUI testing in industry. And the conclusions that I drew was that, or contributions, were empirical evidence that, yes, you can use image recognition-based testing in industry. Also found evidence that it's feasible over a longer period of time, meaning that you can actually use it over time. There was also some evidence regarding many of the challenges that exist in this field of testing. And finally, some technical and process improvements that I came up with during my PhD work. But now, as a good researcher, after reflecting on this work and also getting more data, I need to present some errata, which I guess is maybe uncommon, but I need to present some errata. So even though I presented evidence in my thesis that showed that technique that I was studying was indeed feasible, some additional results that I've gained since then show that it's generally not feasible. And the reason for this is multiple. There are both political aspects, but also technical limitations with this technique, etc., that makes it so that in most companies, this technology doesn't work very well. And I'll get back to some of the reasons why a little bit later. But needed to took the opportunity to present some errata from my dissertation. So the present then, where are we today with this technology, with UI testing? Well, we have then industry in one corner, and in industry we can look at aspects of UI testing in terms of manual testing that is being performed, technical aspects of automated testing, as well as what I refer to as agile development. And when it comes then to manual testing, why is it still such a big thing, and why is so many companies still doing it and not automating their GUI testing? The two reasons are primarily the experiences many companies have had with previous automation attempts. Many of them have failed and resulted in really high costs for the companies. The tools have not worked out as intended, et cetera, which have left many companies hesitant to even try new approaches when we propose them from academia or even industrial solutions. Another aspect to why manual testing is still a big deal is because of exploratory testing. So most of the testing that I've talked about so far, which is automated UI testing, is what we refer to as a regression testing, meaning that we want to check with our tests that if we have a certain version of the software, we run the tests against that version of the software, we check that everything works, then we update that version of the software, we run the same tests, and if we haven't made any mistakes, the test that worked on the previous version should also work on the new version of the software. However, when it comes to exploratory testing, then you don't have these predefined test scenarios in the same way. Instead, you have humans that click around and explore the graphical user interface, explore the system in order to find new defects and bugs. And that is something that has been very difficult to automate because of the reason that tools and techniques, any techniques, have an issue with identifying, is this actually the right result I gave to this input, right? So that's where you have the human that steps in as the oracle. Then from a technical perspective, there is always been an issue with interfaces when it comes to these technologies, because GUI testing needs to have access to the system, both to send clicks and to receive outputs from the system to evaluate if things are going right or wrong. And these interfaces have then been delimited to certain programming languages, certain technologies like web or mobile, etc. And there are very few techniques that work on any type of system. So therefore, that has been a limitation. When it comes to tooling, many of these tools are quite cumbersome to use. They require quite a deal of technical expertise or certain environments in order to work properly. And this has then also been a limitation for why the technique has not been used that much. And then technical knowledge comes into this also, the need for technical knowledge in order to use these tools correctly. The final thing that is what I refer to then again as agile development, which is what I would say most companies do today, often a hybrid between agile and plan-driven approaches. And here, an important aspect regardless is continuous integration. And what I mean by that is integration of the GUI testing tools into a continuous integration environment. The purpose of a continuous integration environment is to run tests very quickly and give fast feedback to developers to give the developers a sense of, is this a high quality product, or do we need to do more work with it before we can release it to the customers? The problem with GUI level tests is that when you run them, they're very slow. They take a lot of time to execute. One single test case could take in the order of minutes to execute, whilst a unit test, which I mentioned before, which is a test of a very small component, runs in milliseconds. So you can run hundreds of unit tests or one GUI test. And the question is then, where does the GUI testing fit in this environment? And that is not clear. Then another aspect, which is more human focused, is then the mandate and resources that are generally given to developers to properly build these test environments and use these tools in an appropriate way. And this is then also a limitation. So that is a little bit of what's going on in industry and a little bit of the challenges. So on the academic side then, what are we doing in order to maybe combat some of these problems? Well, here are some of the main 4 aspects that we're looking into. So of course, we're looking into new approaches of how to do GUI testing. We're also looking into AI and ML, like everyone else, how to use that in an appropriate way to do GUI testing, and then tools that incorporate these technologies and approaches, and then finally some practices of how to do GUI testing in practice. And the first one then, approaches. Why are we looking into that? Well, one of the reasons is to mitigate these bad experiences that companies have had. For instance, that they're have experienced that the tools or approaches they've used before are not robust enough, that they don't report actual bugs, that they report these false bugs that no one cares about, and then trying to make better approaches to combat this issue, to make the techniques actually work in practice. These approaches are also used then to find new ways of interacting with the software. It could be new types of image recognition algorithms or ways of interacting with different APIs or interfaces in the systems that are being tested. But there is also work here on new types of user interfaces. For instance, who has played around with a virtual headset when you stand and wave with stuff, right? That needs to be tested as well. And since it falls into UI, and GUI is not far from UI, that is something that we're also looking into. Then for AI and ML, one of the more interesting things that we've been also hunting since the early 90s is how to do automated exploratory testing, how to use AI and ML knowledge and techniques in order to generate test cases. We can remove the human completely out of the loop. We haven't done much progress yet, but we're at least trying. ML and AI are used to solve certain technical knowledge challenges. And this is why I mentioned, for instance, this augmented layer type of testing. The idea there is that we create tools that can modify the system we're testing, the graphical user interface, with additional test knowledge that can help the human to do better tests. And that is then these suggestions are generated using AI and ML technologies. Tools are, of course, being developed, and this is to help with the tooling problem. Makes sense. And finally, we have practices. And as you notice here, I've dashed those lines in comparison to all the other lines. And the reason for this is because this is a very understudied area in GUI testing. Most of the focus in all of this research is on technology, creating new tools, techniques, approaches from a technical perspective. But the human is very much involved in this type of testing because we're talking about the graphical user interface. And somehow we've sort of forgotten the user aspect of GUI when it comes to the research. So this is very much an open area of research. So basically what I'm saying is, why is GUI testing uncommon in industry? Because that's basically the outcome of what I said from the last slide. And here, my PhD student, Michel Nass, helped me out quite a lot. You remember I said on the slide where I presented the timeline that in 1992, there were some core problems presented. Lack of how to find buttons and stuff on the screen, and the synchronization problem. These are the challenges that my PhD student found that are the most relevant 2021. And if you look up to the right, it says synchronization between tests and the system under test, and robust identification of GUI widgets, meaning buttons. Meaning that we have the same problems now, which are the core problems as we had 30 years ago. So we basically solved nothing. And these are fundamental problems for the technology. In this graph, we have classified these different problems that exist in essential and accidental problems. Essential problems are problems that we cannot solve. For instance, one of these problems here is called the state space explosion problem. That refers to if you think about the graphical user interface, when you click on a button, you come to a new screen and there are many buttons, and you click on one of those and you get many new buttons, etc. And if you want to test this exhaustively, it takes a lot of time. The number of permutations, combinations of all of these paths grows very quickly. And this is what we then refer to as an essential problem. We cannot solve that problem. It will always exist, but we can mitigate it in some ways. Accidental problems, on the other hand, these are more technical problems that with our current technology, so they are challenges today, but maybe not tomorrow. So hopefully then these two core problems that I mentioned, synchronization and identification, are things that we can solve in the future. The outcome of these challenges, however, for industry is that the performance of the GUI testing tools and technologies that exist is quite poor. You want these tests to be very reliable because their intent is to check if your software is working as intended. But with the poor performance, that leads to issues in can we trust the tests to do so? The second issue is then high cost, because these tests keep breaking all the time, which then means that we have to do a lot of maintenance to make sure that they continue to work over time, which is then not ideal, especially in this agile context where everything needs to be very quick and we often want to run our test cases. And this brings me then to the future. Where are we headed? And if you take then the GUI, graphical user interface testing, I would like to augment that a little bit. So for the future, I would like us to think about graphical tests with user support, which utilize the interface to maintain testing automatically, intelligently, and frequently over time. So a little bit more encompassing definition. The only issue with this is that we get an initialism that is GUI instead of GUI testing. And I've seen worse initialisms for conferences and stuff, so maybe we can get away with it, but we'll see if that sticks, if I can remember it. In any case, if we take a breakdown then of the different components, graphical, user, and interface and testing, what can we do and what has been done, or what's the future in each area? So let's start with graphical. So the first thing that we need to figure out is how do we identify all the buttons and components on the graphical user interface in a smart way? Some research here talks about using multiple locators, as it's called, which are information from the buttons in order to uniquely identify them. Today, the most common tool used in industry is called Selenium, and it's using a single locator, something called an XPath. But you can think about it as just a reference point in a graph. It points to a certain node in a graph. The issue with this single locator is that every time you do changes to your system, that path changes, which means that you need to update your test with the new path. With this technology, it is possible then to use other information about the components in order to identify them, like their position or color or type, etc. And by using multiple at once, it doesn't matter if it moves things around or change it a lot, change some of the aspects, because the other ones would probably be the same as previously. And this allows us also then to uniquely identify components after we've done changes to the system, which is what we want. We want to do regression testing. Another promising approach is then to use machine learning-based image localization. And this is from a paper that is listed down here that you can check afterwards, where they did attempts of using DeepMind algorithms in order to identify components on the graphical user interface as shown to the human. From a graphical standpoint, we also have these augmented graphics that I was talking about. And here's a screenshot from the tool Scout that we're working with here at BTH, where we have the tool shows the system under test, in this case, a web page. And all the different green and blue boxes, etc., are augmentations on top of it that gives additional information to the human tester to make their testing easier. The tool also allows you to just click through the web page to record test cases that can then be automatically replayed without your intervention. So it's very quick to create test cases. It's very powerful in terms of getting this additional support by the system when you're creating tests. However, it's early in its development and it still needs more empirical work and technical work. However, GUI testing is quite difficult. I mentioned machine learning-based image recognition on the previous slide. Here are some results from a paper that looked into DOM-based machine learning technology. And what it tries to do is to identify different types of components on the screen and labeling them as this is a button, this is a image, this is other things. And if we look then at the results, we can see then precision and recall. And if we look at the syntactic data that they use, then the results look okay. They have a precision of 70% or so, and a recall of, well, 90-ish%. But if you look at the real data, when they used it on real systems, it's atrocious. It's below 25%. And so this means that we have some way to go there. Didn't work out so well. However, other technologies like the image-based machine learning I was talking about, here's from another study where they used this Q-learning approach here, and they used image recognition-based approaches in order to explore systems, clicking around in the systems and finding as many screens as possible. And here it showed that the machine learning could have a great effect then in identifying new things. However, this result here wasn't that promising. But it's one out of many, so it's a case where more work is required. Then we have the user, the second part of graphical user interface, right? So the first thing is ease of use. And here it's important then to incorporate more people and users, stakeholders, users of these testing tools. So we can transition from going from the technologies that are commonly used today. It's not that important what this says, but it's just a script written in code, a Selenium script. Moving from that into more dedicated tools that helps the developer to create better or quickly and create test cases into even more advanced solutions, like maybe Scout that we talked about, which augments the GUI. And the question is then, how far and how user-friendly can we make this technology? It's an open research question for the future, and in particular, how we can use this in industry. Another aspect of the user aspect is the best practices. How do we use the tools that we have today in a good way in industry? The reason why I think this is super important is because I have plenty of evidence where companies have used GUI testing tools, like for instance, the Securely tool I mentioned previously, or tools like another tool called iAutomate, which use image recognition and very simple scripts like click image, double click image, drag and drop, type some text. Anyone here could use it. Anyone in this room could sit down and basically start creating a script right away and make it work. And the issue with this is that many companies that have tried this technology, they're, wow, it's so easy to create these tests. It's going to be great. And they start creating tests, hundreds of tests in less than a month. And they're super happy because they have now this big automated test suite. And then you return to them a month later or 2 months later, and you ask them, oh, how's it going with your automated UI test? That doesn't work. Those tools don't work. And you ask them why? Well, the maintenance costs, they are enormous. So we have to spend more time on maintaining them than we can spend time on developing new tests. And then you start looking into why is this the case? And the evidence I found is that these tests are then not created in a suitable way. They don't consider modularization, like breaking out things that are common to many tests. They don't have a hierarchy where things are being reused in a suitable manner. And this leads to then these unnecessary maintenance costs. And so this comment that the tools don't work is incorrect. The development practices of how they were developed, that's wrong. And from what I've seen, there's very little evidence or guidelines from our end to help support this, how to make it better. Well, I saw you, Javi, but for GUI testing. And then we have the interface. So what can we do here? Well, we need to improve then how the interfaces that we're using and how we use them. So first of all, we have the actual graphical user interfaces it's shown to the user. And here we have things like the machine learning-based approaches and image recognition. But then we also have things like using certain attributes of components and using multiple that I talked about. And finally, also these DOM-based approaches. And a small advance that was done very recently, not published yet, don't shoot me, Michelle, was to identify that a technology that has been used for many, many, many years in terms of GUI testing is to use the XPath to identify a single node in this graph. However, what we identified very recently together with Dr. Kopla that visited us before summer for a few months was that if we can identify one of these three last components within the tree here, they generally, like shown here in this image, point to the same component on the visual screen. So it doesn't matter if we find this specific component or that one, all of them are the same visual component on the screen. And we call this then equivalent-based locators. And this is something that has not been published before. And basically what it means is that instead of having one chance in the entire tree to find a certain component we're looking for, we have 3 times as large chance of finding the same component. And this is then a quite significant improvement on existing technology that no one has just not thought of before. So that's cool. And we'll see what we can do with that. Another thing that is quite interesting is to look at dedicated test interfaces. And this is something that, for instance, Spotify has worked with quite a lot, where they embed a specific testing functionality into the system they're testing. So including then test code into the application they're testing. And from the research that I've seen, this is one of the most powerful ways of doing it. Because you increase then the testability quite a lot. However, it's also extremely costly to do this because for every line of software code, you should, in theory, write a line of test code. The only company that I know of that surpasses this by far is Saab. The JAS Gripen aircraft, for instance, it has in the order of 17 million lines of test code for every 1 million lines of source code. Built in this way, which is then unique but very powerful. And I wish more companies did. So then the last part, the testing part. What can we do here? Well, The first thing is then maybe intelligent support. Let's make use of this machine learning and AI knowledge that we have. So if we have a GUI like this, maybe highlight here what we should do next, get some feedback then from the system of how to do it, but also get some feedback or suggestions on alternative inputs. So if I wanted to write hello world, maybe the system could automatically propose hello universe. That might be a better way of testing the system and might result in a crash, which hello world would not. And this is something then that could be very powerful in practice. Similarly, these tools could easily keep track of components and stuff that we haven't tested as much or haven't tested as much lately, and just give us suggestions that we could, as users, ignore or heed and therefore get better testing. The next thing is, of course, robust execution. This was also one of those core problems. And to exemplify this a little bit more, the main issue is that if we have a certain version of, let's say, Google here, and we have another version, you notice that they look a little bit different. And for us humans, it's quite easy to identify that, well, that Google image there is the same as that one over there. The search field is the same as over there, etc. However, what the computer often does is that this orange box that says Google search sometimes end up being I'm feeling lucky. That's the button that it thinks is Google search. And this is something that needs to be reduced in order for developers and testers to be able to trust the test cases. And this is then a core problem we need to solve as quickly as possible. We don't want this to happen. And another aspect of this is that when I'm visualizing it here, these are just the changes to the actual graphical user interface. We have also all the changes to the code, to the architecture and libraries and everything underneath that might have affected how the GUI behaves. And that also needs to be solved. Then we have test generation, where we have aspects of components, multiple buttons or widgets that need to be tested that are connected to other components in a scenario of sorts, which lead to some unique test results. And these types of graphs are quite easy to create, both completely automatically or semi-automatically. And from these graphs, we can generate test cases quite easily, like click on Google, write hello universe, etc. The issue we have is not to generate the graphs or even the test cases. The problem is that we get too many of them. We get too many test cases too quickly. And a lot of them are completely worthless. They don't give any benefit. So the research we need to do here is to how do we automatically identify few good test cases, not many, because industry is not interested in that either, because they don't have time to run all the test cases. Finally, non-functional aspects. And these non-functional aspects then relate to things like security and performance. So an example here would be, let's say we have a form that we want to fill in with name and phone number, etc. What we can do here from a GUI level of abstraction is to record what the user inputs, modify it, and then replay it with other inputs to see if there are any security vulnerabilities. So for instance, here, instead of my name, we could do some code injection with just a link to the index.html, for instance. Very simple example that doesn't work that often in practice, but the basics are the same. Or very large strings, whatever it might be, just to see if there are any potential vulnerabilities that developers have forgotten that we can then automatically test through the GUI. Another non-functional aspect that we could test as an example is in the normal case, when we run GUI level tests, we have one client running one set of test cases against the system we want to test. But if we can scale this up using virtualization, virtual machines or something similar, we can use this in order to do performance testing of different kind. So bombard the system with multiple inputs from fake users that try to buy things off your e-commerce system or whatever it might be. But this is also an area of research that has not been that well developed yet. So to wrap things up very quickly. So some food for thought. First of all, is automated UI testing a good idea? I would like to assume so, and since that's something I've been researching for 7 years, and well, more than almost 10 years. So if we assume that it's yes, how do we overcome these inherent issues, that the inherent issue that GUIs are fundamentally designed for humans, which is one of these core problems why we have problems identifying components and synchronizing things. And if we can overcome this problem, can we solve it with just better locators using image recognition and these multi-locators I was talking about? Or do we need something else, something even more powerful that we haven't even conceived yet? And if yes, if we can solve it with locators, what else than just functional testing and regression testing or even exploratory testing can we use this for? Can we use it for other things? Maybe. And if all of these things are true, why haven't we solved it yet? Why haven't we solved any of these problems in 40 years? Because when I started off with, and this is the controversial ending to the talk, we have the same problems now we had in the early 90s. So maybe we need to move on a little bit. So quick summary. Graphical user interface testing is run on multiple levels of a system. It's used in industry, but not very common. Looking at the past, we see that there's a lot of research into the area and on varying degrees of different approaches and techniques, but there is this reoccurring challenges that needs to be solved, and they're still around today. So we need to put more effort there. Industry, as a result of these challenges, are not using this technology that much, and hopefully we can change that. And in the future, then maybe going to this new, what did I call it? GUI Reservoir technique. I don't even remember the initialism myself, but more advanced type of graphical user interface testing to mitigate these core questions or figuring out the answers to these core questions. And with that, I will wrap up. Thank you for listening. Questions?